101. Logging in from input-constrained devices, excuse me. Let's put our hands together and give her a warm welcome.
Hi, everyone. Thanks, Will. Thank you, everyone, for joining and coming in for this presentation after lunch. I hope you all are awake or will be awake by the end of the talk. So I believe that most, if not all of you, had already experienced device authorization flow. You might not know about it, but you have. So for science's sake, who here doesn't believe they used device authorization flow ever before? Okay, so everybody knows device authorization flow, at least experienced it before. That's good. I was expecting for people to not know, but I guess, given the talk title, you probably already looked it up and figured out. But let's get to it. So hi, I'm Jess. My actual name is Jessica, but only my mom calls me Jessica, and when she's angry, and that's how I know she's angry. But you can call me Jess. That's me. My pronouns are she and her, and I'm a developer advocate at Auth0 by Okta. So that basically means that I talk Python and identity together, going to events like this. Very happy to be here at Python Ohio. This is my first time actually coming to Python Ohio. I've been watching the content from the conference on YouTube for a long time, so I'm very happy to be here. And to find me, the easiest way is to go to my website and /socials, and you can find all my profiles in there that are linked, and you can find me on, YouTube, LinkedIn, Twitter, Mastodon, and I refuse to call Twitter X, but yeah, it is in there too. And anyways, enough about me. So let's talk about input-constrained devices. So when you think about input-constrained devices, you actually have good examples of that on day-to-day basis. And if you think about it, is anything that you don't have a normal input like a computer would have, like a keyboard and a mouse. So smart TVs are considered input-constrained devices. And thank you. Oh yeah, there you go. So you have smart TVs and you have the remote control that you can interact with it and buttons on the TV, but not necessarily a keyboard or a physical keyboard and a mouse. You also have smart fridges that are also considered input-constrained devices. And why is that? Because even though smart fridges might have touch screen, you still don't have a keyboard and a mouse and would have a browser to access the web and interact with it. The other one, and my favorite one, and that's actually me playing video games on my Steam Deck, handheld consoles. Even though handheld consoles do have some sort of buttons in there, and they might have virtual keyboards as well, they are still considered input-constrained devices. Because for me, even though it's a handheld console, I play my video games with my console on the dock, and getting up to type something can be a little bit hard for me, as I am a couch potato sometimes. So you do have virtual keyboard in most of these devices, but if you think IoT devices, sometimes they do not have those. An example of this is this little badge. It connects to the web, and it has Wi-Fi capabilities, but still, I don't have a keyboard in there. And typing on virtual keyboards is not a great experience. Have you tried typing your email to log into your account on a streaming service on a smart TV? You have to go right, up, and then you miss the letter you wanted, so you have to go back and you mistype it. It's just not that great for typing, right? Especially for us that type all day long, so we know a keyboard pretty well. And then you have, okay, but what about touchscreen? That makes it a little bit easier. I'm used to touchscreen. I have my tablets, I have my phone. Yeah, that's better, but it's still not ideal, especially if you're thinking about logging into your applications. And I believe all of you here use password managers. If not, that is a great time to actually start using those. So if you have a password manager, you have passwords that are very long sequence of characters that was randomly generated for you, and you won't have that committed to memory. So you would have to bring your phone or your computer on, open your password manager, read through that thing, try to type it by going with your remote control, right, left. Oh my God, I mistyped it. And just not that great of experience. So how do we solve this? And that's where device authorization flow comes in. it provides a way for these devices that has some constraints when you are inputting information for people to log in a more friendly way. So everything starts with the user. So let's see a little flow on how things work. So I simplified this a little bit for the sake of this presentation, but the main idea is there. So your user wants to access a device and wants to log into a device or an application on that device. So thinking your favorite streaming application. I love watching movies when I have free time. And I want to log into that streaming application so that I can continue watching the movie that I started on my tablet. So you click login, and then it starts. In the back end, you don't see this because your application will be nice enough not to show you this, but your device is communicating with an authorization server. And if that authorization server uses OAuth as the standard, it would have a OAuth/device/code endpoint to communicate with your device. In my case, I usually use Auth0 for my applications. So whenever I say authorization server, think of it of Auth0. And if I say Auth0, think of authorization server. So basically, the device communicates with the authorization server and then asks for information from that authorization server to show to the user. So the authorization server checks the information it received and say, oh, here, a device code, that's basically the ID of your device, and a user code so you can show to your user, and a URL for your user to log in. That's a little bit better. And then the user will see that information on the device screen and will be able to access the URL using that user code as well. So after that happens, after you load that information on the screen, a few things happen in parallel now. First, your user will be able to go through the web flow. You will access a page where they can see the code, where they can put in their user information to log into that application, while the device is pulling on the authorization server every 5 seconds or so to get information from the authorization server. So basically what happened is this. While the user's there using their phone, trying to log in, your device is talking to the authorization server and saying, hey, do you have any information for me yet? And it can say a no, or it can say a yes. And while the authorization server is waiting for the user to log in and put in their credentials, it can say, nope, I don't have nothing for you yet. But once the user actually logs in, the information checks out, the authorization server can then reply with an ID token and an access token. In the case of Auth0 as an authorization server, both of those are JSON Web Tokens, which make our life a little bit easier if you know how to handle JSON Web Tokens. So basically, the ID token will have information about the user, like the user name, profile, maybe the latest movie they were watching. And the access token will have information for your device to call an external protected API. Think of it as your backend. And then, with the access token in hand, your device can call the backend and request more information. Let's say a list of suggested movies to watch after that one that they are watching now. The backend can reply back with that information, and your device can give all of those responses and render that for the user. And you might be thinking, wow, Jess, that's a lot of steps. Yep. Those are a lot of steps. And me particularly, learning this the first time around, it took me a little bit to wrap my head around it. I like to build stuff. I like to code stuff. So when I'm reading these documentations and books about these things on authorization, there are so many moving parts that I think to myself, I need to commit this to memory, and I don't know how. So actually, I do know how, because I learned how to do this before. So I build something. I will build a proof of concept. I will build an application that implements whatever I'm trying to learn for the first time. And then comes in a little device. Because for doing device authorization flow, you need to have a little device you want to implement something in, and that can connect to the internet. And for me, it was the Badger 2040W. I've used these little devices in the past because you can put information from a given user on that. It's very easy to program. Even for people that don't know how to code, they can get started pretty easily And so Primary when he created this device, it has Wi-Fi capabilities. It is an in-ink display, and it uses Micropython, which if you already know Python or are learning Python, is pretty easy to pick up. And I thought like, okay, I like games, but I don't know how to implement games. So maybe somebody already did implement a game for a device such as this. And looking the web, I found this one, which is the Dino. Some of you may have encountered the Dino before. If you use Google Chrome, when the internet goes down, this game would pop up and let you play a little while you wait for the internet to reconnect. And somebody actually did an implementation of it for the Badger 2040, which is a different version of this device that I have here. So it implements the game logic. Basically, the little character there that is a dino, a dinosaur, is going to jump over the obstacles. If you hit the obstacles, you lose, and the game is over, and you start again. So I thought, like, I have a device, I have a game, let's get to it. So I have my badge with the game. A player will play the game, and then once they hit an obstacle, the game ends, and they press an option so that they can upload their score to the web. In order for that to happen, my device needs to talk to the authorization server, in that case Auth0, pass along some information that Auth0 needs to know what application is talking to, and then once everything checks out, give back to the device a device code, a user code, and a URL. Now think of device code is the ID of that device for the next coming request that we're going to need to make. With that in hand, the device can then update the screen and show a QR code and the user code so the user can double check. And what the user is going to do is basically scan that QR code and go to a page on their own device, their phone, for example, which is a way better way, well, which provides a way for you to actually type in the information. And while the user is doing that interaction, Auth0 is actually serving that page for me. I do not like particularly to build those pages, so Auth0 does that for me, which makes my life a little bit easier. And while the user is trying to fill in the information, like the username, password, or connecting with a social connection, the device is going to make requests to the authorization server every 5 seconds to check on how is the status of things. And once everything checks out, my user put in the information, the username and password, all connected with a social connection. Then the authorization server can communicate back to the device the access token and ID token. And then finally, with the access token in, we can make a request to the backend. And the idea here, the backend is going to be an API, and we'll have a page where I can link the top players on a web. So this is hosted on a cloud somewhere, and we pass along the access token and the score, and then update the page. So that was, my brain wrapping around the idea of device authorization flow. Okay, now let's get to coding. So I basically put in the game on my own device to make sure it worked. You need to test step by step when you're building something new. And I needed to update a little bit of the code just because the original game was implemented for a different firmware than the one I had. So I updated that. No big changes to the game engine. Thank God, because I'm not that good of a game developer. And then basically what happened was you press 2 buttons, up for playing the game and avoiding obstacles, A to abort the game and go back to the menu. As long as you keep playing, your score will keep going up. And once it finishes, it saves the score to a file. So that's the whole game engine over there. Now, what I did, let's use another button. And one of those buttons we can tie into actually uploading the score. So I updated the message, and now it presses up to start, A to abort, shows the last high score that was played on that device, and B to upload the score. And if the user presses B, what the device will do is try to make sure that it's connected to the internet first. If it is not, it will connect, clear the screen, and then read the configuration from Auth0 that is hosted within the badge. Finally, go through the device flow process, which I here called DF for device flow, and log in for the whole thing. I know, not the best of names, but for learning purposes, it was great. And then finally, once he has the access token back, he can make a request to the endpoint on my API. So all of this, because I at least try not to have everything into the same script, and I wanted to keep the game logic separate from all of these other new things that were related to talking to an authorization server and my external API. I put everything into little modules, separated, imported into my game script. So let's take a look at each of these steps. So first, reading the configuration. So when you set up your Auth0 account in your application, you get client ID, client secret, domains, which algorithms is used to sign the JSON Web Tokens you're going to receive, like the ID token and the access token. And the audience, which is the address for the API you are trying to communicate after the protected API. So basically, we put that into a file so that your script can read. I just read the lines from the TXT file, put everything inside of a dictionary to make it easy to access later, and return that at the end of the function. Then I started my device flow process. So we are going to make 3 requests. The first one, they want to let the authorization server know that we are trying to connect and log in a user. So that starts by passing along the client ID, the type of scope of action, so basically getting the OpenID profile of that user, and the audience, which is going to be the API they're going to talk to. And then I make a request, a post request to the OAuth device code, passing along all of that information to the authorization server. Then, if everything went okay, that's great. We can then use the response from the authorization server, which will have a bunch of information. It will have the device code, the device ID that the authorization server will give me, the user code so that the user can check the confirmation for the confirmation page, and the URL that the user needs to access. With that, I can then draw a new page on the device. Because the screens of the device are very tiny, putting the URL was not an option. And I couldn't shorten the link. So what I did was, let's go the QR code route and basically use the URL, turn that into a QR code that somebody could scan with their phone. And I also showed the user code on the screen for the user to confirm. Then finally, for the second request that we need to make to get the tokens, we set up everything. So we need to pass what type of grant we are using. So for device authorization flow, we use the device code grant that was ratified on OAuth 2, and that's the information that we have on grant type. We also give it the device code, which is the ID of the device that we are using, and we pass along the client ID so that the authorization server knows which application we are talking about. And then we prepare the URL for that with some of the information for the domain of my server. Then we go into that loop that is going to happen every 5 seconds to test whether or not the user confirmed and logged in to the authorization server. So while the user is not confirmed, we keep making post requests every 5 seconds. Now, there is a caveat there. A device authorization flow has a time that you need to go through with all of the requests that you need to make so that you can have your user log in. And that comes into that first request you received, what is the expiration date for all of these requests. So you need to double check both if you received an error and if the time is already passed, because if it is expired, you should not interact with it anymore. So assuming that your user, everything worked out, and your user confirmed and logged in, you will receive back the tokens, the access token and the ID token, and then you can make requests. Okay, this was a lot of code, a lot of steps. They reproduce all the flow that we saw before, but what does that look like for a given user? So basically, the user is seeing that QR code over there and scanning the QR code. If any of you scan this QR code, it's going to show, this is out of date, it's not going to work. So you can see that that's my phone, and I see the yellow bottom line that shows the link that we are trying to scan. After accessing the link, the user will see a page such as this. I customized it a little bit, put a logo that is kind of cute over there. And the device confirmation page shows the link, the user code on that page, and the user can either cancel or confirm. And given the fact that we are talking about happy paths here, the user is going to confirm this one, and then go through the signing process or sign up process. Now notice there that the cursor is already on the email field, so that's why you get prompt to use your password manager. So this is just the built-in password manager from Apple in this case, because I was using an iPhone, but it could be any other password manager that is set up on your phone. And then you would go through the flow of signing in. I particularly don't use username and passwords other than have that as an example. And I went with the Google login route. And once I log in or sign up, I get a confirmation on my mobile that everything went well. Congratulations, you're set, your device is now connected. And under the hood, what is happening is Auth0 is preparing the access token and the ID token so the device can request those. And now, the device received the ID tokens and the access tokens. That page is going to be updated as soon as I finish making my request to the backend. So basically, I take the access token, I prepare the authorization header, prepare the bearer on the front of the access token, and I make a request to my API. I just hit the API URL there, and to what I'm calling is scores endpoint, and I pass along the user score as part of the query params for this URL, and then I make a post to my API. Now, I didn't tell you this before, but this is a great example to show a little bit of a difference between Python and Micropython. So Python, you would have to use, well, not have, but you probably would use something like requests or HTTPX, my two favorite libraries to make requests over the web. But MicroPython does have a library within its own standard library that is the U requests. And you can make posts, get requests, and all the other ones to communicate over the web. Once the score is set, everything works well. So on the leaderboard side, my leaderboard and the API was built with FastAPI, because I think it's simple, pretty easy to get it up and to code everything that I need. So I used the HTTP bearer checker as a dependency to make sure that we had the authorization header within every request that I receive on the scores endpoint. And I prepare the score that comes from the query params from the request that I received on that endpoint. I make a check on my access token from the authorization header to make sure that it is a JSON Web Token and was signed by Auth0 and so on. So also the API will have information on the application that is set on your authorization server to validate that token. If the validation doesn't go through, this will fail. But if it does go through, then we can create a record within our database for a given user. And I'm not saving usernames or emails in my database. I'm saving the user ID that comes from Auth0, so that if this fails, nobody can do anything with it anyways, because it's an internal ID. And then I will either create a new record for new users or append the score for users that already played the game before. Thank you for the time check. Now, you might notice there that my database is just a JSON file, simplicity's sake. But it could have been any other type of database that you want. Now, the other endpoint for this API is actually a page that is going to render my leaderboard. So I use a leaderboard.html template that is HTML with Jinja in it to show some information. So I want to show the top 10 players every time, and if I don't have players, I will show there is no players yet. But up until 10, that's the ones that I want to show. So I sort them through the score, and then finally prepare a data set to show within my Jinja template. Now, because I have the ID of the user that is stored within Auth0, I can then query Auth0 to get information from those users, like saying the username on the leaderboard. But what I did was actually to get the user profile photo because I thought it looked cute to have the little photo of the person that got that score. And then I just prepare a dictionary so that I can show that information, both the user picture and the score next to it on the leaderboard. And let's stop talking about it. So this is what the page looks like when we have no players. And this is what the page looks like if you do have players. That's me. When I did 3. Apparently, I can only do 3 as a score. I did 13 once, but I don't do well on these games. I'm a cozy gamer, not a competitive gamer. And so I think we still have time for demo, maybe 4 minutes, yep. So I recorded a video a little bit for you to see me trying to get some scores in. So that's me playing earlier today. See, failed. Let's see that again, and it works. So I can jump over the obstacles, yay, victory. And I managed to jump 2 at a time, but then I don't do well on the second one. So I press B to upload my score, and then it tries to connect to the authorization server. And this is connecting for the first time to the internet. It blinks a little bit. Once it connects, it shows that it's connected. And then it takes a little while, but it renders the page with the QR code and the code for me to double check. And you can see that the phone already identified the QR code. I can access that. That's my browser. And as soon as it loads up, I can see the confirmation code, and I can confirm and go through the login process. So there I have the prompt, but I would just use Google because it's easier. And once it loads, I can choose which email I want to access that with. And it takes a little while because, 5G was not that great. Congratulations, you're all set. And then we go back to the game because I didn't show any in-between pages. So basically what it does is restart the game so you can play again. And that's it. So takeaways, because I spoke a lot, there was a lot of code, there was a lot of learning, and a lot of flows over there. And first, the device authorization flow can provide a better experience with your user than try to type over virtual keyboards and a remote control. So if you are in the position of providing that type of login to your users, it's way much better. Second is basically 2 flows put together. The device flow where the device communicates with the authorization server, and the web flow where the user communicates with the authorization server. So if you want to think about it in a more simple more simple way, that's the way to think about it. And login doesn't need to be painful if you don't have a keyboard. That's one way out. You can just use something else's keyboard in order to log in. And you can also use device authorization flow for other things like CLI. So let's say you're a developer that are connecting to a server and you need to do things through the command line only. That is the way to go. You can get the link on the CLI printed and then access that on your phone to log in and confirm and so on. And on a more personal note, if you're studying things like this that have a lot of steps and it's a little bit complex, try implementing the concepts at least once so that it commits to your memory like it did mine. I've been really successful in understanding these things. And if you have any questions, I would be happy to answer them in the hallway. And if you want to grab the slides, those are available on my website on jtemporal.com/PyOhio24. Both the slides and the code for the game with the updated for device authorization flow are there. That's it. Thank you. One time note for those of you that are already here, we have an event coming up from Auth0. So if you like device authorization flow and cool things like this, it's going to be a 24-hour live stream and on September 24. So on 24, you can scan the QR code to register. I would love to see you there. There will be a bunch of us having fun and chatting and answering questions. That's it. Thanks all.